page 800, Geometry Mod 5, Topic 1, Lesson 2, and we're finishing up the conversation on compound probability with the word and. We want you to compare methods that we've discussed in these last like 12 to 15 pages on how you simplify the thinking behind figuring out the compound probability of situations involving and. Well, for both independent and dependent events, we multiply the probabilities. I should say probability fractions, right? Because there's always been the idea of like how many events or outcomes have the desired result that we want out of like the total number of options. If you're talking strictly independent events only, then it's just probability of the first event, so probability A times probability B, and you just continue multiplying out for forever. For dependent events, it's a little bit like more specific. You have to consider that you're first of all going to multiply probability of A. So like what's the probability of the first event, A, happening? But then as you continue to have further successive events happening, when you multiply, it's now got to be the new event given A happened. And that really could continue on. Like after you do probability of A, then it's probability of that event given that A happened. Then it's a probability of that event giving both of those happened. So we got to consider them together. So probability of, I'll say C, given A and B happened. And so there's some really heavy notation, and this really does continue on and on and on. Dots, not X's. Okay, because we're multiplying. If we want to take a rule, these are essentially the rules. So I guess in question 2, what rules could you write to determine the compound probability of 3 or more independent events or 3 or more dependent events? It would literally look like this. Probability of A for independent times probability of B times probability of C times probability of D, and so on for as many events as you're stringing together. Be careful. The more events you have, the tinier and tinier the odds of that happening get smaller and smaller. Courts use this to prove conviction of a criminal because the likelihood the criminal was or wasn't that person, they're stringing together probabilities and then saying, aha, it's highly unlikely because it's such a small number. There is some fallacy to that, so you got to be careful. Compound probability of dependent events. I've already outlined it in question 1, but it looks like this. You got to know what the probability of A is. But once A has happened, the next events rely on the previous events to happen. So now we're down the path of B, and if there are more probabilities, like a C probability, then it's the intersection. If there's a D event, then its probability is based upon A and B and C all together, and it would continue on and on, so on. So as every time some new event is being tested or compared, we got to base it upon the previous events happening. Talk the talk. Thanks for watching the video. Lesson 2 is done. It's all about and. When we get into our next video, page 803, we'll be talking or, and I'll just give you a heads up hint. Or means plus. Thanks for watching this video. Like, comment, and subscribe.